How to use the Ethernet IP client function block located in the GPL library to read Ethernet IP objects from the TeSys Island. The goal of this video is to demonstrate Ethernet IP explicit communications from the M580 to a distributed I/O device, in this case a TeSys Island over Ethernet IP. I will be using the Ethernet IP client function block located in the GPL library. The GPL library is not pre-installed in Control Expert, therefore it needs to be installed. I have included two links, the links to the GPL library. Please follow the installation instructions on page 13 of the release notes, and the TeSys Island third-party integration manual that will be used as a reference in this video. In this demo, I'm going to be reading the vendor name attribute off of the TeSys Island. In the TeSys Island third-party integration manual on page 69, you can find all the objects that are supported for Ethernet IP explicit messaging. The vendor name attribute I'm interested in is under System Asset Management, where the class ID for this object is 69, instance ID is 1, and attribute ID is 1. To save time, I've already incorporated the logic as shown. This function blocks Ethernet IP client, statistic, counter, and Ethernet IP port. Function blocks are located within the general purpose library under communication. So if I go under data selection and I expand the emoticon library under communication, you can find the Ethernet IP client, the Ethernet IP port profile function blocks, as well as the statistic counter. Now let's take a look at the input pen of the Ethernet IP client function block. The star enables the client to send a request. This is the Ethernet IP service ID. A hex value of E indicates a read request of a single attribute. Class ID as instance ID and attribute ID were explained earlier. I'm going to read the vendor name off of the TeSys Island, where the class is 69 and instance and attribute is equal to 1. This is the device IP address. In this case is the IP address of the TeSys Island. Priority of the requests. Lesser the value, higher the priority. Typically 3 is used for read operations. Bytes that are being sent out. Data to be written along with the EIP header. This is the client engineering parameters. We need to go into the editor to enter some values for retries, timeout, and inactivity time. Client data is a DDT structure that contains all the client data, and the word memory is the memory area that contains the client reference. This is a very important parameter, and it needs to be linked with the Ethernet IP port function blocks. As far as the output pins, there are some status indicators related to the request, if it's busy, if it ended, if it failed, etc. The response data is the data received from the TeSys Island. By default, it's an array of 2 integers. You will have to modify the size of the array accordingly to make sure the array is large enough to receive the data from your Ethernet IP device. The statistic connector needs to be connected to the statistic counter DFB. If you notice, I have a variable called TeSys_statistic, and this is the same variable name used on the input pen of the statistic counter DFB. The statistic DFB is not mandatory, but it is recommended, as it logs the statistical data of the request handled by the client. Pretty straightforward block, with an enable and reset pins, the connection to the Ethernet IP client function block, and an output pin for the data. The Ethernet IP port function blocks, this block is mandatory. It won't work without it. The Ethernet IP port function block will manage the requests generated by the client to a physical device via the work memory. Several options are offered here: 4, 16, 32, 48, 80, and 96. The last number at the end indicates the maximum simultaneous explicit messaging allowed depending on the hardware being used. On the input pin, we have the initialization, the enable and reset statistic. The engineering parameters will have the details of the Ethernet IP ports. In other words, we need to go into the editor and enter the address of the physical port the message is coming out of. The variable name for the work memory will have to be the same name used in the Ethernet IP client function block. So in other words, you can see that the work memory variable is the same on both function blocks. Typically, this block will need to be after all of the Ethernet IP client function blocks. Now let's go into Data Editor to modify to take a look at some of the engineering parameters.
This is a preview file.
So here's the engineering parameters of the Ethernet port. It has the port address, simultaneous sense, and the timeout. Notice the address shown here. I have in between single quotes a 0.2.0. In this case, if I go under my PLC bus, my data is coming out of a NOC module located on slot number 2. This is why I have 0.2.0. If you were to have your Ethernet IP device connected on the device port on the CPU, your address would have been 0.0.3. But in this case, again, because coming out of a NOC module located on slot number 2, my address is 0.2.0. And also for the Ethernet IP client function block on the engineering parameters, you will need to enter some number of retries in case of communication failure, as well as timeout and inactivity time. Logic has been built and is been downloaded into an M580. So now let's just test it. So I'm just going to set this enable bit to 1. It's going to generate a rising edge after 2 seconds, and it seems like it executed the request. So if I select these two blocks and right click and initialize animation table, under TeSys vendor response, I can see some values. This is the response data. And if I select them all, right click and change the display format to an ASCII value, so you can see that Schneider Electric was the value returned from the TeSys Island. You can also see some static data. This is the output of the statistic function block, where you can see number of requests being sent, number of requests that ended successfully, and the amount of time spent on the request, etc. So now what I want to do, I want to turn this off for a second, and I want to make an online change. I'm going to create another request. So I'm just going to copy another Ethernet IP client function block. And this time I want to read another attribute. I want to read the MAC address off of the TeSys Island. So for that, I had to change some variables. So I'm just going to replace the vendor variables with the MAC variables. It's going to create some variables for me. I'm going to remove the statistic connector because in order to be quick, I'm just going to delete it. And also I'm going to change the attribute. So the MAC address attribute is 7. I'm going to change that to 7. And notice the EIP work memory is the same because it uses the same physical port. I'm going to build changes.
This is a preview file. For example use only.
I'm going to enable this pin one more time. And after 2 seconds, seems like it executed the request. And now if I do initialize a new animation table with the MAC response, I can see some values. And if I change those values to a hexadecimal format, that is the MAC address returned from the TeSys Island. This concludes the video. Thank you for watching.